Hello, everyone. We'll be starting in 5 minutes. Hello, everyone. Let's get started. I hope I'm clearly visible and audible. Okay, thank you. Okay, so let's get started. So today we'll be talking about the next topic which we have. So let me just share the screen first. Hello, everyone. Um, Okay, let's get started. So we have already talked about the data engineering and what is this case study. So we have talked about what is this data science and all those things we have already covered, and we have completed a one of the module which we have is Python. Right? So today we'll be starting with the next module which we have is SQL or databases. Right. Now, where does the database stands in the whole data science or data domain itself? So when you talk about databases or data sources, that defines to us. So here we have discussed about this particular part. Just a moment. So a while. Okay. So what we have done is when you talk about the databases, so today we'll be studying about the term as databases. Now, what is this database? Now, database is a kind of a data storage unit which tends to store a data for the software engineers and software developers also uses the databases. And we as a data scientist, data analyst, we also uses the databases. We have already covered one of the case study, right? That bank case study which we have covered. Now, there we have a normal customer transaction which is going on, which has been handled, which has been taken care by the applications, right? Now it can be a web application, it can be any kind of mobile application also. Uh, Application is always connected to a database, right? A database, it is always connected to, right? So database, we have SQL type databases, we have NoSQL type databases, we do have API sources because we are talking about the data sources also. So that is the different types of data sources which we have. Right? Then we have a blob storage also. Now, these are the different types of storage systems which we have, data sources which we have. And when you talk about these two parts, that is what we have as a databases. These are the two what we call it as the databases. Now, what are the databases? They are the primary source of data storage unit, which we use in the case of regular OLTP transactions. Now, what do we mean by the term as OLTP? OLTP refers to online transactional processing. Right? Online transaction processing, where whenever you log into your mobile app, whenever you log into your web browser, onto a banking app, onto anything, whenever you're logging into the server, whenever you're logging into a website application, what happens when you click on login? There's a command runs to the data source, to a database, which verifies the detail that whether the login details which you have entered is it correct or not. When it's correct, it will come back to you onto that same web page, onto that same login screen, and allow you to come forward to the next part. And whenever there is new data loading up, that is what every time whenever you're making any click, any change, whenever you're making any window change, whichever you're making, every time whenever you're making any kind of click, every time there's a transaction happening. Okay. Where every time there's a transaction happening between the data sources and the application. Now, effective management of this particular thing, effective management of getting a data to the user from a data source, right, and presented in a efficient way, presented in a UI based or user friendly way, is what we call it as software engineers, right? That is what we have already covered. That is what we have as the software engineers, software developers, DB, and all those people goes into this particular part. Then we talked about the OLAP transactions. Then we have is OLAP transaction. Now, OLAP transaction is more like when your user database has been happening, when your users are getting connected to the data sources, and you're getting the data or you're sending, now you want to use the data additionally to do the analytics. Now you want to utilize this data to give customers more personalized scenario. That is what we have as a OLAP. When you want to use this data for the analytical processing, that is what we have as a OLAP. So what we are doing here, we are performing ETL, right? Here we are performing ETL jobs, extraction, transform, and load. So we are extracting the data from data sources, transforming it, which means cleaning of data, putting them in an all structured manner, making it in a smaller pieces so that we can efficiently use them, and then loading them to a big data technologies. Now, big data technology, big data storage unit, you can also say. So that can be a data warehouse, or that can be a data lake. Right? So it can be anything. And whenever any data scientist, data analyst needs the data, they are using this particular big data storage unit to get a data for their analytical purpose or for a AI purpose. So either you're doing a BI, which is business intelligence, AI, which is artificial intelligence. So whenever you want to feed a data to any kind of BI tool or to any kind of artificial intelligence, that is where we use this big tech or the big data technology part, right? So that is the part that is the importance of having a databases. Right? That is the major importance of having a databases. Now, question might be here that why do we use the API? So API does get connected to this. Blob storage can also be connected to this. Whichever data sources you have, whichever kind of all the data sources you have, you can connect all of them to a big data technologies. Right? Now, coming to the actual topic of databases. Now, what exactly is the database? Simple term, database is just a storage unit. Okay. Whenever we talk about a term as databases, it is just a storage unit, right? Now, databases are of two types, majorly of two types. We have is SQL and we have a no SQL databases. Now, what do you mean by the term as SQL? Now, when we talk about the SQL, it refers to structured query language. SQL refers to structured query language. So it's a language, it's a coding language which we use to get a data from a data source. Now imagine it like this, that we all store data in our hard drives. Like we all have a laptop, for mobile phones, right? And every device nowadays have a some small amount of storage unit in them, right? And whenever we are storing a data, now it can be Excel file, it can be PDF file, it can be movies, it can be songs, it can be images, videos, anything it can be, right? So when how you are fetching the data? Can anyone tell me how we are fetching a data? Suppose if you're using a Windows or you're using a phone, when we have a mobile phone, when we have a device, in that how we are accessing the data, how we are accessing the data which we have stored in a data in the hard drives in the storage unit of our devices. Anyone? So with the help of operating system from disk or from RAM, yeah, with the help of all over, it is helping us that that's the main operating system which is helping us, the boot storage and the operating system which is helping us based on UI, you're able to access that storage unit to that particular part, right? Similarly, when you want to access a data in a database, that is where this SQL language comes into play. That is the helper language. That is the language which we write. So whenever you want to get a specific amount of data, or whenever you want to get a specific data from a whole the data source, that is where the SQL comes into play. Right. Now you can see it like this, that where does the database stands. So if I draw one more flowchart diagram, so here you might be having applications available, right? Any kind of application it can be web app, it can be mobile app, anything, right? Website, anything. And here we have a DBA, right? Data administration team, which is managing up all the data which is getting stored into the data sources into a database. Now they both are connected. Now we are introducing a new term as DBMS. Now what is this DBMS? DBMS refers to database management system. So it's a system, right? If you talk about DBMS, it's a database management system. Now, what is this database management system? It's a system which is helping us to manage the database. So as we said, database is just a storage unit, right? Database is just a storage unit, just like a hard drive, like just like a hard drive, which we are using to store any kind of data, right? Where we can store any kind of data, where we can throw any kind of data, right? But how are we managing that? Now that DBMS is nothing but that operating system in which we are writing those SQL language, because we do not write SQL language over here. We write SQL language over here in this particular part, that language part. We are writing it in a DBMS. That is which helping us to access the database. And the DBMS, when you're writing up, when a DBA person, when a application, whichever application we are using, when this write a SQL, whenever they send a SQL signal to a DBMS, it reads it, it understands it, sends the query to database, right? Sends the query to database, and then it fetches the data back. The database sends back the database to DBMS, and then DBMS is the one which is distributing the data as per the requirement. Suppose an application wants to go to next page, right? Suppose if you're using a news application, now whenever you click on sports news, instantly you get a whole length of sports news, right? Whenever you click on Instagram and open up any page, you get a whole list of posts, right? Then how is it happening? So whenever you make a click, a, a signal from the application was sent to DBMS. It asks for which kind of, so there here we have a SQL query which has been written by the app itself, which has been written in the program of the app, which is sent to the DBMS, and then DBMS sends to the database, fetches back the database, fetches the data from the database, and sends back to the application. So all the database, which is all the data which we are collecting, which we are storing, is all been managed by the DBMS. Clear, everyone? What is this DBMS? And the types which you have written over here, that SQL and NoSQL, these are the types of DBMS. So when you talk about SQL type DBMS, or when the SQL language, when you're using a SQL language to get the data from database, that is when we call it as a RDBMS, Relational Database Management System. Relational Database Management System. So when you're using a SQL as a language to read a data from a database, that particular part is what we call it as RDBMS, which works with the SQL language. And which do not work on SQL language is what we call it as a NoSQL databases. Okay, those are what we call as NoSQL databases. Now there we have multiple categories of databases. Here we have multiple categories of databases available. So first we have is columnar databases. or DBMS or databases you can say. Then we have is, okay, let's go with the examples you might have heard about. Let's go for the examples directly. So first type of DBMS which you have is Redshift, or let's say it could be Cassandra, which is more simpler name. So first type of database which we have is Cassandra. Then second type of DBMS. Now these are the actual database examples I'm giving you. For RDBMS, we work with MySQL. That is one of the DBMS. Another one we have is Oracle. These are the different types of DBMS which are available. Okay, the ones which I'm writing now. These are the different types of DBMS which are available right now, which we can work with. So in the case of RDBMS, in the case of SQL type databases, we have MySQL, Workbench, Oracle, PostgreSQL, and many more. Similarly, when you talk about a no SQL type, now here we have a Cassandra, MongoDB, and then we do have graph database also. So these are three types of different types of non-SQL, no SQL databases which are available. Now they do not actually work on the SQL language. They have an individual language for themselves. They have an individual different languages which we'll be learning moving forward. Now, if we take our simple examples over here, right? Now, if we talk about an SQL example, now where is it actually being used? Let's talk about that, right? So when you talk about an SQL type database, whenever, suppose if we take an example of a banking system, now which all kind of data can we store in the form of tables, in the form of rows and columns? Which all kind of data, if we talk about example of a banking system, which all kind of data we can store in a table-like form? Can anyone tell me? Which all kind of data can we store in the table-like structure in the form of Excel? Which all data can we store? Anyone? So we do have a different types of data, right? A table-like data, like if you talk about a transaction data, right? The transaction data, which all kind of data can it have? It can have a date of transaction, time of transaction, who did that transaction, and where it went, right? What is the amount of transaction in the banking system, right? These are the details we can have. Now here we can have additionally as sender's bank or receiver's bank, right? We can have these kind of details. Now this kind of data can be easily stored in the Excel-like format, right? In the Excel format, in a rows and column-like format. We have different rows for like column name as date, column name as time, column name as like sender's name, receiver's name, then bank account details, and so on. Right, that is the detail a table can store. And similarly, we can have a lot of transactions going on in the similar format, right? Now, whenever you want to work with a table-like structure data, type of data you mean. Okay. So we talked about this in initial classes, but let's talk about the data also. So we do have three types of data available. Okay, if we talk about data types, or like data as a types of data. First, we have is structured data. Now we have already covered this. So first we have a structured data. So what is the structured data? Whenever we are storing a data in the form of tables, like rows and columns, the ones which I have just given you example. A data which is stored in the form of table like structure. It can be transaction data. It can be uh, register, entry register. right? All the people who are coming in, going out, attendance, records, all this data can be easily stored in the table-like structure, right? In the rows and column format, in the Excel format, right? That is what we call it as a structured data, a data which is a predefined structure. Then we have is unstructured data. We have a unstructured data, a data which does not have a predefined structure, right? A data which does not have a predefined structure. Now it can be audio file, can be images, it can be videos, it can be any kind of text file, it can be a document, right? Anything can be considered essay, writing essay, right? All these can be called as a unstructured data, right? Simple example can be a form, the form which you're filling up, or an application you're writing to the bank, right? A simple application, hello, like to the manager, branch name, and then the body may you can write anything. Right? That is what we have as an unstructured kind of data. Right? Whenever you are just storing images, right? You're putting a signature over there, images, right? Whenever you're doing a KYC, thumbprint, that's again an unstructured data. So these are the different types of unstructured data which are available. So these are the major two types of data which we have. Third, we have is semi-structured data. Now, what do we mean by the term as semi-structured data? A data where we have, if you take an example of an email, email have receiver, CC, BCC, then we have his subject, then we have his date, then we have his body, then we have his attachments, right? Any kind of attachment if we are adding, right? So this is the partially defined structure. Reason being, when we talk about this body part, now this body can contain of any kind of data values. Right? Here we can have any number of data values. This body can consist of data of a meeting. This body can contain a data of a advertisement. Right? So this body can have any kind of data available. Right? And that is what we call it as a semi-structured data. When a structure of data is partially structured and partially unstructured. That is what we define as a semi-structured kind of data. So these are three types of data which we have, which we deal with whenever we are working with the databases, whenever we work with the different kind of data sources. Clear, everyone? Clear, everyone, with the different types of data sources, databases? Yes, no? Please confirm. Great. Moving forward, now if we think of the same example, as I said, SQL stores structured data. Right? SQL stores the structured data, and that is why they are called as structured query languages. A language which helps you work with the structured data only. Now we can store images also, but it is generally preferred to work for a table-like structure of data or a structured data only. SQL uh, databases are generally used for a structured data only. Similarly, if we talk about these NoSQL databases, now here there's an add-on part comes into play. Now first we have is Cassandra, which is a columnar type database. MongoDB is a document-based database. And Graph is a or GraphX is a graph-based database. So these are the three different types or categories of databases which are available in the case of NoSQL databases. Now, if we take an example, and for specifically for MongoDB, all the kind of can anyone tell me what all kind of data our Aadhaar card stores? I believe everyone would be having an Aadhaar card, would be having a social security number, would be having an Aadhaar card, will be having a government ID proof available, right? We do have all the we do have or we must be having at least one government ID available, right? Yes or no? right? So when you talk about Aadhaar card, which is India's social security number or India's main ID proof, that is actually Aadhaar card is using a MongoDB. In real time, all the data of our people, all the kind of data which we have in an Aadhaar card is stored in this MongoDB. Now, which are kind of columns do we have in Aadhaar card? Can anyone tell me? Which all kind of data can an Aadhaar card store? Which all kind of data can an Aadhaar card store? Like if we look out our data Aadhaar card, which all information do we get from that Aadhaar card? Name, Aadhaar number, address, name, Aadhaar number, address, gender, date of birth, number, and photograph. It does have your thumbprint, right? Whenever you go for KYC, they can take your thumbprint also. Right? They do have eye scan also. So if you went to the if you went ever remember when the Aadhaar card was created, yes, iris scan, right? Eye scan they have, thumbprint they have, right? And they do have now they have connected this to the PAN cards also. All the PAN cards are now connected to the Aadhaar card, which means they are storing your income related details also now. Right? So there is a huge amount of data which is available. Now, if you talk about photos, if we take about eye scan, if we take about images, like thumbprint and all those, then if we take an example of these numbers, Aadhaar number, address can be different structure, right? So it can have a, and that is why it is using a NoSQL data type, and it uses a MongoDB, which is a document-based structure, right? Which uses a document-based structure. Clear, everyone? What is a MongoDB? Now we will be studying this MongoDB in very much detail moving forward, as this is our part. Right? This one and MySQL are the two databases which we are going to studying moving forward. Obviously, there are a lot of databases which are available, but others will be covering as a overview. But these are the main two databases, two different types of databases which are most commonly used in industries. Okay, so we will focus more toward these two. Now, coming to one example of Cassandra. Okay, now okay, I remember one more example of MongoDB. Now, if you think of example of MongoDB, whenever we make a search, let me just show you that one. This one we can show and we can see as well. So let me just share, change the screen. So if we take an example over here, if I go here, so if I simply go to the Amazon, let's say, okay, I opened up an Amazon here. So if I search for anything, let's say iPhone, okay, I just search for the iPhone, right? So when I click on it, what I get a lot of images over here, name, then pricing, icons. There are a lot of data is coming up at once. And when you click on it, now you can see instantly within a second, you're getting all the images. You're also getting many times here we have a video also available. There's a lot of detail like this also available. Images, coloring options, all the different types of options which are available. Then here you can see a lot of details, images they are available. Comparison. So there's a lot of data which is available whenever you click on it. And that is the benefit of using a MongoDB over here. Reason being, it stores all the data, a specific detail. It stores all the data of a specific person or specific detail all together. Right? So here, whenever you make a search in this iPhone 15 Pro or anything, whenever you make a search over here, it needs to get all the data at once. Right? And that is why it is using a MongoDB because it's a document-based database. Similarly, when you talk about Aadhaar card, based on that Aadhaar card ID, it needs to fetch all the details. It can be iris scan, it can be thumbprint, it can be images, it can be all the details, it can be income details also. So it is fetching all the detail at once with the help of one single click, right? And that is the benefit of using a document-based databases. Whenever you need to read one data, one point at a time, that is where the databases, these type of databases come into play. Clear? Now moving to the second type, which we have is Cassandra. Now moving to the second type, which we have is Cassandra. Now what is this Cassandra? Where it is used? Now if you think of example of a Netflix. Now can you tell me what is comparative to the data which is available, or comparative to the data who is watching the data, who is watching that movies, or who is watching the content on Netflix or YouTube, right? Compare, let's take an example of Netflix specifically, because Netflix does use a Cassandra database. Now, the benefit of using a Cassandra database is that it is very fast to read. Cassandra databases are very fast to read the data, whereas writing data is slightly difficult. And that is a property of using a columnar type databases. So we do have different examples of columnar type databases, but Cassandra is one of the more commonly used one. So Cassandra is one of the columnar type databases. And the properties of columnar type is that they are very fast to read, but slightly difficult to write. So if you think of example, because Netflix actually uses this Cassandra, the people who are reading the or who are consuming the content of Netflix is very high comparative to the people who is adding the data to the Netflix. Right? We are able to relate with this. People, like, because Netflix creates mostly his own content, right? Netflix generally creates his own content. He does buy the content, he does buy the famous content from other vendors also, but generally tries to create new content, right? So even if he is buying content from other vendors, plus he is creating his own content, right? And the content which is he is adding to his data source, whereas the people who is more interacting to that Netflix data source to consume the data is comparatively very, very high. Consumers are very high, whereas new data coming in is very low. Right? Because writing operation is very low, reading operation is very high. That is why Cassandra is very highly used in the case of Netflix. Are we able to relate with this one? Yes or no? Right? Now, give me one example of graphics. Let's understand this graph database and think of one example for this graphics technology also. Okay. Now, GraphX is like a graph kind database. Okay. We are connecting the dots over here. We are linking all the data which is available. They are all connected to each other based on the graph-like structure. Right? It's like this kind of structure. If I have to create this one, if I create a graph database, so suppose this single node contains all the data of a particular person. Right? Here we have one detail. Then this detail is connected to this detail. Then this detail is connected to this one. Then here it might be like this. Here we can have multiple nodes also. Right? So here this is how, and it is going on and on. Okay, it is going on and on. Can anyone think of any example for this kind of database? That where is that possible that most of the data points are connected to each other? Where can we use this kind of database properties? Can anyone think of it? Are we able to understand this one? Which kind of properties are we looking at? Now, in the case of MongoDB, what happened? We are collecting a single document, which is connected to a word. In the case of Cassandra, it is connected to Word, but it is mainly used for reading operation. But here, all the data points, like all the movies are connected to each other. That is more like this kind of graph. We are connecting all the movies to each other. That is what we refer to as all the connections of movies. How the movies are connected to each other. Yes, LinkedIn. LinkedIn is a very good example because LinkedIn actually uses a graph database. Because here you get a recommendation as first level connection, second connection, third connection, and so on. Right? You do get that kind of connections. Similarly, with the job portal, which LinkedIn have, the job portal, there also they're suggesting you the different data jobs which you're looking at. Whichever kind of job you start looking at, it will start showing you the relatable jobs on and on. Right? So LinkedIn is the one which uses a graph database in their server because graph database provides you with the inbuilt property of recommendation. It automatically provides you with a recommendation by default, and that is why graphics is very highly used in the case of LinkedIn part. Clear everyone up to this part? Anyone having any questions so far? Anyone having any questions so far? Okay, sure. Let's take both example. So LinkedIn is one of the example where I know that this one is highly used. Graphics is highly used because okay, Indeed is another example. Oh, sorry, not Indeed. Naukri.com. Naukri.com is also one. Okay, have anyone used about? Have anyone heard about the website called as Monster.com? Anyone heard about the term as Monster.com? Anyone heard about this website? Yes. What it is used for which purpose it is used for? Monster and Shine, right? So Monster.com was the original idea for that job portals. Like nowadays we have Naukri.com, we have Indeed and LinkedIn also we can use to search out for jobs, right? Monster.com is the original one which came the very first. But nowadays it has not been used. Why it is so? Because Monster.com uses a regular database, right? They are using a regular database, whereas when the Naukri.com came in, Naukri.com came in, and similarly, LinkedIn came in. They both came with the graph database. Okay, they used a graph database because they need to recommend the jobs very fast. In the case of Monster.com, what happened? Now they are not, they have to suggest the jobs with the additional algorithms. Right? They have to put on additional pressure onto the servers to start recommending the jobs to the people. But in the case of Monster.com, what used to happen? You have to search the job yourself. It will not recommend you anyway. You have to search yourself. But in the case of Naukri and LinkedIn, what happened? They started recommending you. That is the new feature they added when they was introduced into this market, right? And they started recommending the job, which helped the user very fast. And that is why they become more famous, they become more active, whereas Monster.com was dead, almost dead now. Right? That is the reason behind the these two to go to the success because properties of databases actually make an impact. As as we said, graphics is a by default, it's a property of the same as it is recommending. It is by default itself is a recommending kind of a database. It automatically starts recommending the data based on whenever you pick up on any dot, based on the connected data points to that particular dot point, based on that particular all the data points, it will start recommending you. That is the by default property of a graphics. Right. So these are the different types of properties which we have with respect to each and different databases. Now coming to the third example as Cassandra, as someone was asking for the Cassandra understanding. So let's think of one example of Cassandra also. Now if you think of a Cassandra, let's say, okay, let's take an example of this SQL or let's say example of a MongoDB. Okay, and if we take example of a Netflix itself, right? Now if we take an example of a Netflix and MongoDB, let's say, let's imagine that Netflix is using a MongoDB instead of a Cassandra database. Now, what is the main purpose of our Netflix? Do they want to show them the data fast, or do they want to show the details fast? What they want to show? Tell me, guys. So, if you go to a MongoDB, let's imagine that Netflix is running on a MongoDB, right? Now, what will happen? So, whenever you click on any movie, it will start showing you the whole details first. Will it be good option? Yes or no? Or do you directly want to, when you click on movie, you want to directly read that movie? Which one would you prefer? Second one, definitely. Now, Cassandra, over there, now there's an advantage of Cassandra. That is the main property of using a any kind of columnar method. Okay. Now, here also, the examples which I have given, Cassandra, MongoDB, GraphX, these are the examples only. The type of NoSQL database is what we have as a this one. These are the types of database: columnar database, document database, and graph database. These are the examples of the same. Like here you can see RDBMS is the type of database and MySQL is the example. Similarly, columnar database is the type and Cassandra is the example. Document-based data type, document database is a type and MongoDB is an example of type. Graph database is the type and GraphX is the example of the same. Similarly, we have a Neo4j also available, right? But they are all based on the graph-based databases, right? Now, if you have an example of a Cassandra, now you that is a property of columnar. Oh, and if I give you one very really interesting fact, so if you guys have worked on MySQL, you must be knowing. And for people who do not know, there's a context which has been created by all those man companies where they tend to look out for how fast they can read a data. So originally, if you have to read a 1 TB of data, okay, 100 TB, sorry, not 1 TB. If you have to read 1 TB of data in MySQL with the most efficient query, it takes around 8 hours. If you want to read 100 TB of data in MySQL database, in the RDBMS type database, it takes around 8 hours of time, right? So obviously you can imagine how much time it is taking to present a data. And obviously we will not be the one, because if you take an example of a Netflix, it does have more than 100 TB of data. So if you start taking MySQL over there, it will be taking a lot of time to even show you the data. After that, loading and everything is later on. But first, you need to get that movie which you're looking for, right? And that is the disadvantage of MySQL. But if you talk about a columnar database, if you have unstructured data and if you're using a columnar database, in that case, columnar database can read same 100 TB of data in less than 15 minutes. All 100 TB of data in less than 15 minutes. Can we see the time difference? That is the advantage and disadvantage of using a different types of databases in different perspectives. Are we getting this? Now we will be studying all of them in a much more detail so that you can understand how and why they have been having that kind of property available. Right? We will be studying that in more detail, but that is about the more general concept. Is it clear with everyone to this part? Is it clear with everyone? Yes, no? Great. So that is about the different types of databases which we have. And moving forward from tomorrow itself, we'll be starting with the SQL type databases. So if you guys have any kind of question, query, doubts, please do let me know. Anyone who have a question, query, doubts, and people who joined new today, if you guys have any related doubts, can let me know related to the topic, related to the course, anything. Anyone having any question, query, doubts, can let me know.
Sir, I have one doubt. For this,
Yes.
all this database, are we using the different language for coding or a specific language for specific database we are using?
every database which we talked about have every different types of database have their own languages. Like if you talk about SQL or like that RDBMS, they all work on a SQL like SQL language. Right. Similarly, if you talk about columnar, it uses a different language. Similarly, document based uses a different language. Similarly, when you talk about the graphics, it uses a different language. So all of them different uses a different language. But as we said, we are more focused on two types of languages, which is one as a SQL, which is very important one because most of the time we are dealing with a table like data. Right? So that is why we'll be more focused toward the SQL language, and SQL language have a more advantage in the big data technology also. That is why we'll be more focused toward the SQL language. Additionally, moving to the NoSQL databases, we'll be studying about MongoDB, as MongoDB is very effective one in the case of NoSQL databases for a more generalized systems itself. Right. So that is where we'll be using a MongoDB as our data source, which will be starting from a NoSQL databases. And then we'll be having a short briefing towards the Cassandra and the graphics database also.
Sir,
Duration of course is 3 months. Yes, Abhimanyu.
which language we can use to fetch the data from the MongoDB, sir?
Sorry.
Which language we can use to fetch the data from MongoDB?
MongoDB have its own language.
What's its name, sir?
Sorry.
What is name? Language name, sir.
Okay, language name. So language is MQL, which is Mongo query language, MongoDB query language. Similarly, Cassandra also uses CQL, and graphics uses a Neo4j. So all of them have its own languages. Sorry, graphics uses Cypher, not Neo4j. Neo4j is the type. Cypher is the language which uses a graph database. Clear?
Yes, sir, clear.
Sir, what
Including,
will be the
yes,
duration for the total course? Like,
it's a 3-month course.
okay. And what cloud technology you will cover? Like, it will be based
So
on
we'll be more
Azure.
focused. We'll be more focused toward the Azure cloud technology. But additionally, we'll be spending a briefing of the AWS also. But more focused for the Azure part. We'll be doing more practical on the Azure part, but we'll be doing one project on AWS services also, so that you can have a briefing about the AWS services and AWS cloud itself. Because all the clouds are almost the same. It's just the change of services and the way we are implementing them. If you know about one cloud service, others are easy to grab.
So in that 3 months, we will cover the project also, or project will take another some days.
No, projects will be covered in the same. That's really more like a practical part. You'll be
Hmm.
learning more things with the practical part. Theory will be very less because data engineering is not a theory subject. If you talk about data science or data analyst, they do come with a lot of theory as well, which you need to study. And in this one, we will be trying to cover because data engineers, in the very first session, we talked about the same. Data engineers does uses different data engineers as per the company levels, tier 1, tier 2, tier 3. Based on that, data engineers are the one who are working as a data analyst as well. And many times there's small applications of data scientists also. So we'll be covering those aspects of data analyst and data scientist as well on a very smaller note, but we'll more focus for the data engineering, which is more as a practical stream, practical career, and we'll be more practical, doing more practical rather than working on the theory.
So are we covering data pipeline also?
Definitely, it cannot be left out if we are doing a data engineering.
Okay.
Like ETL part, which I have talked to you in just now in the previous example, that is what we have as a pipelines. That is what we implement using the pipeline itself. CI/CD is more like a DevOps part. Okay, that goes into the integration of the development when you're putting things on the production environment. That is where we need a CI/CD pipelines, not the ETL pipelines. ETL pipelines, those kind of pipelines are different in the case of data domain on that OLAP part. that CI/CD is applicable in the OLTP part, which is been taken care by those DevOps and the full stack developers.
Yeah, sir, the total course will cover by you only, or the some other trainers will be in the frame?
By me only.
Okay, okay.
Anything else if you don't have? And the format also goes the same way. Yes. Yes, first.
Hello, sir.
Yes. Hello.
Sir, I have a question of SQL.
Mm-hmm.
What
go
is
on.
role in SQL?
What is row in SQL?
What role? What
It's a
is the
role of
function of
SQL.
a
Okay,
role?
role of SQL. It's a language, no? It's a language to get a data through with the help of DBMS. It is helping you to yes. Sorry, come again.
Okay. Okay, sir. Thank you.
So it helps you, like you write up a SQL command, it goes to a DBMS. DBMS fetches you the data which you're asking in that command. The coding language, you can say, to be like in very simplest form. It's a high level coding language which you write like English, that you say, I want to get this kind of data. I want to get a, suppose if I talk about myself, from that, let's say I go to a bank transaction. I want to get all the transaction detail of with the name as Sahil Garg. So you write that in a SQL code, that query which you are looking for. You transform that in the form of SQL language. You write it as SQL language. That language goes to the DBMS, gets you the data from database, and gets back to you with the data. That is the role of SQL, to fetch your data.
Sir, I have a question. One
Yes.
more.
Go on.
Sir, when we start our database,
Mm-hmm.
why we connected with sysdba and we write /? What is the role of /?
Forward slash where I didn't get it.
Sir, when we start SQL plus,
SQL plus.
सर जब हम SQL प्लस स्टार्ट करते हैं तो वो हमसे सबसे पहले पूछता है एंटर यूजर नेम। हम लिखते हैं /as sysdba।
That is for the DBMS part, no? That is the DBMS where you're logging into the system. DBMS, like when you enter into your laptop, it asks for your password, right? So that is where you're telling it that these are my login credentials which you're entering over there. And because these are a server-based system, that is why you put a slashes over there.
Okay, we put /.
Yes.
Sir, why we write sysdba? Why we not write sys?
Because this DB refers to database administration's database administrator.
Okay. Sir, why it does not show the password?
Because they are hidden, they are kept to be secured. Even if you go to the Linux, now in the case of DBMS, it does show you ****, right? In the case of Linux, if you go there, it even do not show you star also. So that is just to keep it safe.
Okay.
People who have the credential can only access it. It's not like a social media login where you can click on the show password and it will show you the password. They are very, very secure. To keep it even secure, they sometimes even hide that *** also, so that you cannot even see how many number of values do we have, how many number of count we are adding over there. That's just a security layer which you are adding over there. And even recovering of password are also even very,
Sir,
very
why
difficult.
every
Yes, go on.
Sir, why every user in a database has its own schema?
They have no schema is one only. It's just that they are given access to a smaller piece of it, whichever is useful for them. They have given you that much access.
Sir, for
Like if
example,
I'm
Scott
accounts
has its
person,
own schema.
no, if I'm accounts, like suppose if I talk about a company have all the database collected in a database only. All the data, all the storage is been done in a single database. But suppose I'm from accounts, so I'm related to the accounts detail only. I'm not interested in seeing the what kind of customers I have and so on. I'm just interested in looking of what kind of transactions has been happening. So I'm working on that part. Similarly, if I talk about salespeople, now salespeople are looking at the customer related and the products related part. They are not looking into the accounts part of the company. Similarly, if I talk about HR part is looking at the admin that employees detail, not looking to the sales detail. That is what they are given access to particular tables only. That is how you have a different schemas. But when you talk about
Okay.
DBA part, data managed administrator, he have access to everything.
Sir, what are synonyms in SQL?
Sorry,
Synonyms.
synonyms. What
Synonyms.
synonyms?
S.
What synonyms are you
Yes,
talking
it is
about?
a part of SQL.
Synonyms.
Sir, we write synonyms. We write synonyms in SQL. What is the function of them?
No, we don't need the synonyms in the case of SQL in our case. If it's a part of DBMS, then for sure they'll be needing it. But we don't need, as a data engineers, we don't need synonyms over here.
Okay. Sir, who was the founder of SQL?
No
Dr.
idea
E.F.
regarding
Code?
that. Sorry,
Who was the founder of SQL?
I have no idea for that. As I
Sir,
mentioned,
I
it's
have
not
read
going to
that
be.
Dr. E.F.
Sorry,
I have read that Dr. E.F. Code was the founder of DBMS.
sure, he might be. I don't remember him. I mean, I don't remember that name.
Okay, sir. Thank you.
Most welcome. Anyone having any other question, query, doubts? Okay, so that is all we have for today. Thank you, everyone.